Hello, students. Good morning. I hope you all are safe and healthy at your home. Welcome in our lecture. In this lecture, we are studying about power generation. The generation of electric power is one of the most important application of an energy sources. Solar thermal power cycle can be classified as low temperature cycle, medium temperature cycle and high temperature cycle. According to our syllabus, we will studying two low temperature cycle and medium temperature cycle. In low temperature cycle, we studying about standard power generation system and chimney power plant, and in medium temperature power generation we have only one instrument. So we start with standard power generation system. In thermal application of solar energy, power generation is one of the most important applications. So here describe the figure is standard power generating system. There are two cycles in power generating system. One is water circulating system, which is described as a blue color, and second is Rankine cycle, which is described in red color. So we start our power generating system. Low temperature cycle work at maximum temperature of about 100 degrees Celsius. Low temperature system use flat plate collector or solar pond for collecting solar energy. A diagram of typical low temperature system using flat plate collector and working on a Rankine cycle is shown in figure. So the main part of the power generating system is flat plate collector or solar collector, and the turbine and condenser. In energy of the sun is collected by water flowing through the array of flat plate collector. In above lecture, we studied about array. More than one flat plate collector is arranged, then this type of system is known as array. In order to get the maximum possible temperature, booster mirrors which reflect radiation onto the flat plate collector are sometimes used. The hot water at temperature close to 100 degrees Celsius is stored in well insulated thermal storage tank. From the storage tank, it flows through a vapor generator through while the working fluid of Rankine cycle is also passed. The working fluid has low boiling point constantly, vapor at above 90 degrees Celsius and a pressure of few atmosphere leaves the vapor generator. The vapor from execute a regular Rankine cycle by flowing through a prime mover, a condenser and liquid pump. The working fluid normally used are organic fluids like methyl chloride, toluene, butane and some refrigerants like R11, R113 and R114. So we get continuous power generation by this type of system. Some of other schematic diagrams are also described here. This is also the power generating system. This is also the power generating system, and here we saw the receiver which is receive the concentrated solar radiation by heliostat field. Now, in this type of power generating system, we have one instrument also, the solar chimney power plant. In solar chimney power plant, a tall concentrate or central chimney is surrounded at its base by circular greenhouse. You saw the figure. This greenhouse consisting of a transparent cover supported a few meters above the ground by a metal frame. Sunlight passing through the transparent cover catches the air trap in the greenhouse to help up a convection system is set up in which this air is drained up through the central chimney, turning a turbine located near the base of the chimney. The hot air is continuously replaced by fresh air drained at the peripheral of the greenhouse. The only solar chimney power plant built so far is 50 kilowatt plant in Spain. I give some detail of this plant. It has a 200-meter high chimney, 200-meter height chimney with a constant diameter of 10.3 meters. The solar collector area extends to a radius of 126 meters from the chimney, with the glazing being 2 meters above the ground. The turbine house at the base of the chimney has 4 to 5 meter long blades, 4 to 5 meter long blades, turbine blades, and rotate at 15,000 rpm, 15,000 round per meter, to produce at about an output of 50 kilowatt power generation. And last point, the efficiency of such plant is only 1% energy conversion. So this is the information of first solar chimney power plant in Spain. This is also a figure of solar chimney power plant. This is also show a schematic diagram for solar radiation and how air is heated in solar chimney power plant. This is also the one of the diagram for the solar chimney power plant. In this diagram, we show the thermal storage at day and night. How day solar radiation is stored and how in night. This is different type of solar radiation for more power generation. Now, our last topic for this lecture is medium temperature system. Medium temperature system. Medium temperature system work at maximum temperature up to 400 degrees Celsius. We studied about low temperature system which work at 100 degrees Celsius, maximum 100 degrees Celsius. Medium is maximum for or up to 400 degrees Celsius, and high temperature is more than 400 degrees Celsius. Medium temperature system use the line focusing parabolic collector technology. A schematic diagram of a typical solar thermal electric power plant operating on a medium temperature cycle and using the focusing parabolic concentrating technology at a low temperature at about 400 degrees Celsius is shown in the figure. We show the next figure. This type of system is work at 400 degrees Celsius temperature. The cylindrical parabolic collector use have their axes oriented north-south, which are lined with mirror to collect and concentrate the solar radiation. The absorber tube used is made of steel and has a specially developed selective surface. It is surrounded by glass covers with a vacuum. The collector heat a synthetic oil to a temperature of 400 degrees Celsius with a collector efficiency of about 0.7 per for beam radiation. The synthetic oil is used for generating superheated high pressure steam which execute a Rankine cycle with an efficiency of 38%. The plant generally produces electricity for about 8 hours in a day, 8 hours in a day, and coupled with natural gas for the continuous operation. This type of system is medium temperature power generating system. This is also the figure for this type of medium temperature system. I have some videos for power generating system which is attached here. See the video. First of all, we see about Rankine cycle. In Rankine cycle, there is heat exchange in heat exchanger. The hot fluid is passed and low boiling organic compound get heat and vaporize, and they transfer this energy into mechanical energy. So turbine runs and we get electricity. This is Rankine cycle. And after completing cycle, the fluid is condensed in condensers. This is condenser. Solar power plant. Solar radiation is absorbed. Hot fluid is passed in heat exchanger and it is replaced by cold fluid. Working fluid is water, air, oil, etc. It is passed in heat exchanger where it is exchanged and then it is passed into generator which generates the electricity. So this is the actual situation of power generating system and we get electricity. At night it is run by our other energy sources. Solar chimney power plant. This type of central chimney is arranged in central and paraboloid concentrating collector are arranged which reflect the solar radiation. This is the arrangement of power generating system and we get electricity at our house. This is another solar chimney arrangement, engineering arrangement of chimney. We also arrange more than one turbine as described in this video. In a day, solar radiation is passed and air is heated. So the temperature difference in a day. At mid in day, there is temperature is very high. and efficiency of hot air is also very high. So the speed of turbine is high in actual chimney power plant. This is housing which absorbs the solar radiation. These all are solar chimney power plant. This is also a figure for power generating system. Here is three cycles stated. One is from solar radiation, second is thermal energy storage, and last one is power block. Okay, thank you.